Now we'll continue on with part C from question 1 with the function f of x equals 1 minus 2x over 3x plus 2. So we can find a few things here to do a quick sketch of the graph. So we take a look at this, we can look at the vertical asymptote, and the vertical asymptote will exist when the denominator goes 0, which is when the function does not exist. And we can just solve for x here. And so the vertical asymptote is x equals negative 2 over 3. Then to get a general feel for what the graph looks like, I can find the x and y intercepts. So the x-intercept occurs when y equals 0. And so then I can set 0 equal to 1 minus 2x over 3x plus 2, multiply both sides by the denominator, which drops that out. So we get 0 equals 1 minus 2x, and then you get negative 1 equals negative 2x, therefore x equals 1/2. And then, finding the y-intercept, we can maybe squeeze this in over here. The y-intercept occurs when x equals 0. Therefore, when x equals 0, we get zeros in both of those, so y equals 1/2. So the y-intercept is 1/2, which I'll put here. The x-intercept is 1/2, which I will place right here. And the vertical asymptote is negative 2/3, which I will slide in right around here. And then for the horizontal asymptote, sorry, this doesn't have much order to it, so I'll put horizontal asymptote over here. Horizontal asymptote occurs when x approaches very, very large numbers in both directions, which means that as x approaches positive or negative infinity, y will be 1 minus 2x over 3x plus 2. Well, as we saw from the other example, if Warren Buffett found $1, is that going to change his general wealth? No. If he found $2, that also won't affect his current status either. So we're left with negative 2x over 3x, and we simplify that to get negative 2 over 3. So the horizontal asymptote is negative 2 over 3, and I will just place that around here. And we see that because of the x and y intercepts here, we can see that the curve, this one branch, is going to be kind of going through here. So it's going through these two intercepts and then down towards the horizontal asymptote in this direction. And then the other branch is going to be in the other side over here, approaching those two asymptotes. Okay, so then now we just have to analyze the graph as it approaches the asymptotes. So I would have to say that as x approaches negative 2/3 from the left, so as x approaches negative 2/3 from the left, we say that f of x approaches negative infinity because it's going down to negative infinity there. As x approaches negative 2/3 from the right, it's going in this direction, we see that f of x is approaching positive infinity. And then as x approaches negative infinity, going towards the very, very large values negative, f of x is approaching negative 2/3, the horizontal asymptote from below. It's coming up from below. And then as x approaches positive infinity, f of x approaches the same horizontal asymptote of negative 2/3, this time from above. So it's coming down from above there. And then for part 2, well, we've kind of already analyzed it. The limit then of f of x as x approaches negative infinity equals negative 2/3, and then the limit of f of x as x approaches positive infinity equals negative 2/3 again. Now we'll continue on with part D. I'll try to be a little bit more organized in this case than I was in the last example. So look at here the vertical asymptote. Again, when the denominator equals 0, so when 1 minus x equals 0, so therefore when x equals 1 is where the vertical asymptote occurs. The horizontal asymptote we get as x approaches very, very large values, y equals x over 1 minus x, but the 1 doesn't really affect anything, so it's x over negative x, which gives you negative 1 when you simplify. Then to get an idea of what the graph looks like, we'll look at the x-intercept, and that of course occurs when y equals 0. And so then when y equals 0, 0 equals x over 1 minus x. Multiply both sides by the denominator here, so therefore x equals 0. And for the y-intercept, that occurs when x equals 0, therefore f of x, or y of course, f of 0, let's substitute the 0 in there, we get 0 over 1 minus 0, and that just equals 0. So y equals 0. So we've got this function crossing through the Cartesian plane at the origin, and we have a vertical asymptote at x equals positive 1, and we have the horizontal asymptote at x equals negative 1. I'm just going to draw it out here because it doesn't really come into play near the origin at all. It's only when x values get really, really large. Now here, because the x and y intercepts are the same values going through the origin, we have a hard time really getting a good idea of where the graph is going to go. If I look back at this example here, we see that the x and y intercepts are situated such that we can kind of see where the graph will go just by following through those two intercepts. But now when we only have one intercept, it's a little bit more tricky. However, we know that the graph is going to approach the vertical asymptote and then approach the horizontal asymptote. And if I were to draw the graph such that it were to go towards negative infinity down towards the vertical asymptote, it would, if it went through the origin, it couldn't approach the horizontal asymptote here unless it kind of did a quadratic sort of route and bounced off the x-intercept, or sorry, the x-axis, and curved back down. But because of this function, it's a fairly simple function, it's not going to do that. There are no squares in here, so it won't give a quadratic route there. So I'm pretty safe to assume that the graph is going to approach the vertical asymptote and go towards positive infinity, and then as x gets large negative, it'll approach the horizontal asymptote from above, and that only leaves one other place for the other arm to go, and that'll be in the bottom part here, so that as it approaches the vertical asymptote from the right, the graph will go towards negative infinity, and as the graph approaches x equals, or as x approaches positive infinity, the graph will approach the horizontal asymptote from below, which we will now analyze here. So as x approaches 1 from the left. So as x approaches 1 from the left, we see that f of x approaches positive infinity, and then as x approaches 1 from the right, coming in this direction, we see that f of x is approaching negative infinity. Then as x approaches negative infinity, all the way here, we see that f of x approaches negative 1 from above, and then as x approaches positive infinity, f of x, the function, approaches negative 1 from below. Okay, and then we'll take a look at part 2, which is determining the limits. So the limit of f of x as x approaches negative infinity, that equals negative 1. So it approaches that horizontal asymptote at negative 1. And then the limit of f of x as x approaches positive infinity, that is also going to equal, of course, negative 1, the horizontal asymptote.